This is Unit 2, Lesson 4, Geometrical Transformations. Students will use matrices to perform translations, reflections, rotations, and dilations on the coordinate plane. So we're going to introduce matrices today, which we're going to use to solve linear systems later. But today we're going to use them for something different. But in order to do that, we first have to know what a matrix is and how we can use it.
So in order to talk about this, we first have to talk about what is a matrix. And all a matrix is a rectangular array of numbers written inside brackets. So it's just kind of like a chart. There's a certain number of rows, certain number of columns, and they're full. And you just write brackets around the whole thing, and that's a matrix. One of the things we can do with matrix is to take a shape on the coordinate plane. So one of the things I can do with matrices is represent the vertices of a polygon. So that would allow me to draw this polygon on another graph if I so chose. And it works like this. Each row of the matrix is one of the points that makes up a corner, and each column would be, the left column would be the x-axis coordinate, and the second column would be the y coordinate. So you can see here this shape is represented by the matrix that I wrote on the left. One of the points is -2, 4, one of the points is 1, 4, one of the points is 1, -4, and one of the points is -5, 1. So we can draw that and make a matrix. Now once we have that shape, we can perform certain transformations on that shape and do some interesting things to it as we move it around the graph. One of the things we can do is move the shape without changing its orientation or size. So in this case, I'm going to move the shape 2 units to the left, and I'm going to move the shape also 1 unit up. And I'm going to rewrite a new matrix, a green matrix, that has the coordinates for the corners of this shape that I've moved along the graph. Moving the shape like this is called translating. So this is a translation. So now the new points are like this. We have -4, 5. We have -1, 5. We have -1, -3. And we have -7, 2. And you'll notice what happened on this is because I moved it 2 units to the left, the first column got subtracted by 2. So -2 gives us -4, 1 gives us -1, 1 gives us -1, -5 goes -7. That's because we moved it 2 units to the left. If we had moved it to the right, then we would have added 2. And the other thing that happens is the shape moved up, so we added 1 to the second column because that's the y coordinates. So 4 becomes 5, -4 becomes -3, and 2 becomes 1. If we have moved it down, we would have subtracted it by however much it is. This is called a translation. Something else we can do to the matrix is take all the numbers in the matrix and multiply it by the same number. In this case, we'll multiply it by 2. So when we do that, -2 becomes -4, 4 becomes 8, 1 becomes 2, 4 becomes 8 again, 1 becomes 2 again, -4 becomes -8, -5 becomes -10, and 1 becomes 2. And what that does to the picture, and you can see that that big green one now has all those points from the green matrix on it. That increases the size of the shape by a factor of 2, and what that's called is a dilation. If we want to make the shape smaller instead of larger, we'd have to multiply by a fraction, because multiplying by a fraction is what gives you a smaller number. Be careful not to multiply by a negative. We're going to see what happens when you do that later. So in this case, we're going to dilate the figure by 1/2. So we multiply all the numbers in the red matrix by 1/2. So -2 becomes -1, 4 becomes 2, 1 becomes 0.5, 4 becomes 2 again, 1 becomes 0.5 again, -4 becomes -2, -5 becomes -2.5, so 2.5, and 1 becomes 0.5. And you'll see what happens is that makes the figure half the size as it was before. So you're kind of zooming out, it looks like. So that's dilation. Multiplying by a number larger than 1 is going to give you an increase in size, and multiplying by a number smaller than 1 is going to give you a decrease in size. I cautioned you against multiplying by negative numbers. So let's see what happens when we multiply just the first column by -1. So all I have to do is rewrite my green matrix. I just change the signs of the first column. I leave the second column alone. And what that gives me is a kind of a flip. And if you look at this, if I look at the shape together with both of them drawn, you'll see that the line of symmetry for that whole shape is the y-axis. So what I did between the red and the green is I flipped the shape and I flipped it across the y-axis. So if I wanted to switch it across the x-axis, I would have to do the other thing. I would have to multiply the second column by -1 rather than the first column, because that would change all of my y coordinates. So that's what I do. When I multiply the second column by -1, and you can see that I did that there, I just changed the signs for everything in the second column. That gives me a flip across the x-axis. And you can tell that because if you look at the two figures together, the x-axis is the line of symmetry. Okay, so I already multiplied the first column by -1. I already multiplied the second column by -1. What happens when I multiply both columns by -1? And that's what the new matrix looks like. And when I draw that shape, the green shape, you can see what happens. What happens when I multiply all the numbers in the matrix by -1 is I have a rotation of 180 degrees. Okay, something else that I can do with the matrix is to switch the columns. And so I put the first column second and the second column first. That looks like that. Notice I didn't do any math for all that. All I did was write the second column at the beginning and the first column at the end. Now that shape ends up looking like this, which doesn't look like much. It's clearly not a rotation. If you want to go back in time and look at what we saw, you'll see that when it rotates, it doesn't look like that. It's going to be upside down from that. So it's not a rotation, it's not a translation, it's not a dilation. But if you look at it really closely, you can see that there is a line of symmetry between those 2 points. That's the line of symmetry. So what you really did was flip the shape across that line. The equation for that line is y equals x. So this is called the reflection across the line y equals x. Sometimes you'll see that. That's what you get when you switch the 2 columns. So you switch the x and the y coordinates. Now let's take it one other step. Let's switch the columns and then multiply everything by -1. So I did the same thing. I switched the columns. I changed all the signs. If you want to check that, you can. And what that gives me is this shape. And again, it's not a rotation, it's not a dilation, it's not a translation. It has to be a reflection. And in this case, it's a reflection around that line. So it's a reflection around the line, and that line is y equals -x. So when we switch the columns and then multiply everything by -1, we get a reflection across y equals x. So we switched the columns, and we've switched the columns and multiplied everything by -1. So now we've had all the reflections we're going to see, and we've had one rotation that's of 180 degrees. But I'm going to do a different rotation. I'm going to do 90 degrees clockwise. So if we look at the shape, a 90-degree clockwise rotation looks like that. Okay, so now we have to figure out what the matrix is. So I write down the same points. In this case, I get 4, 2, 4, -1, -4, 1, and 1, 5. You can check those. They're the points of the green shape. And what this is now I can look at the two matrices and compare them. Now what happened is clearly the x and the y coordinates are switched again. But after I switched them, I multiplied the second column by -1. The -2 becomes 2, 1 becomes -1, 1 becomes -1, and -5 becomes 5. So in order to get a 90-degree clockwise rotation, you first have to switch the x and y coordinates, and then you have to multiply the y coordinates by -1. So we've pretty much done everything. We've multiplied the first column by -1. We've multiplied the second column by -1. We've multiplied everything by -1. We've switched the columns. We've multiplied the second column by -1. We've switched the columns and left it alone. We've switched the columns and multiplied everything by -1. The only thing that's left is to switch the columns and then multiply the first column by -1. So this is what we get when that happens. We switch the columns, we change the first column, we change the signs of the new first column, and we see what that is. And what that we find is that is a rotation of 270 degrees in a clockwise rotation, in a clockwise direction. So what you should have in your notes, and I'm not going to write this for you, you should have this chart. If you do this to the matrix, this will happen to the figure. We did 10 different things to the matrix, and we had a corresponding 10 things that happened to the figure. In order to do your homework, it's going to be really easy if you have these rules written down all in a row in one place. I would suggest you do that before you start your homework, and I'll give you your homework on the next page. Here's your homework, page 46, 2 to 16 even. Make sure to read the directions carefully, and if it asks you to make a graph, you need to make a graph. Okay, I'll see you in class next time, and thanks for listening.